This is an mTEC plate. This is used to quantify the amount of E. coli in a water sample. This sample is from the Santa Monica stormwater runoff. So I took about 100 milliliters of water and I made some dilutions. I believe that this one is, I wrote the dilutions on the back here. So this one is, let's see, it's about 10 to the negative 2 dilution. So that means I took 100 milliliters of the water sample and then I diluted it 2 times, 2 tenfold dilutions. Anyway, so I wanted to show you this mTEC here. This is to do the membrane filtration method to look for E. coli. So this is the mTEC plate. Now it looks like I already showed you, it looks like this. I don't know if you can see that next to the microscope here. I have it in a dissection microscope. So it's a pretty small plate. Let me zoom in and zoom out on this dissection microscope, and you can see these colonies. These purple ones are the ones that you want to count. Now on this one, it's been in the incubator more than the 24 hours, so some of the colonies are grown together a little bit. You have what's called confluent growth. So 2 of them that might have been next to each other kind of grew together and formed one. You can kind of make out that this one right here might be 2 or 3 that grew together. And some of these other ones might be just one, like that big round one. Usually it's just one if it's round like that. But if it has some of them that have grown together, then you'll see 2 of them at the same time. So like, for example, this one right here in the middle there might be 2 grown together. Anyway, so I wanted to show you this for mTEC. It's these purple ones. See these yellow ones here? These are interference bacteria. That's just background bacteria that happen to grow on the plate. It usually grows when you leave it in the incubator too long. I counted them and then left them in there, and then I made this video so you can see that. And here's the mEI plate. This is another one. mEI is incubated at 41 or 41.5, 41 degrees C, while the mTEC that I had there, that was at 44.5. So the mEI again is at 41 degrees C and the mTEC is 41. mEI is for Enterococcus. So what we have here is, if you look at it on the side here, it just looks like blue colonies, but when you see it in the microscope here, you can see that they're actually white colonies with blue halos that you're looking for. So so when you get the big ones, they start to get a little bit white in the middle. There's some good example there. The smaller ones still look mostly blue because the blue halo comes out first, but when you let them grow too much, then they start to look a little bit white in the middle. Anyway, you count it as 1 if it's got the blue halo around it. So if it looks like a blue colony, then it's 1. So that's mEI, that's Enterococcus. Now there's other ones you can get, which are the, if it's confluent growth and it grows together and there's too many in one water sample. Then you can get a big problem and not be able to count them, and that would be too numerous to count. So for this particular sample, this is 10 to the negative 2 from some stormwater out in Santa Monica. And this was in December 2nd, 2014. There was a storm there. So let's look at one of these for 10 to the negative 1 dilution, where we just looked at 1 tenfold dilution, and I'll explain that in a later video. But this one, for example, we've got the same thing, blue halos, smaller colonies because there's more of them there, and so there's less media for the colonies to actually use. So the colonies don't grow as big as in the other one. Now let me show you, that's the 10 to the negative 1 again, so you can see that some of these are grown together. Now here is the plate up on the side, so you can kind of see this. It's going to be a plate that looks like there's about 100 or so colonies on there. Now let me show you the 0 dilution one, which is also from there, and you'll see a lot more colonies growing here. Now you can't really count these because it's confluent growth, total confluent growth. They're all grown together. Another reason you do dilutions with this stormwater is that it has a lot of sediment in it. So when the sediment is there on the filter, the sediment will kind of disturb the growth of the actual bacteria. So what we have is this membrane filtration method actually produces some colonies. You'll see some colonies here. When you see it just like this, you'll see that it's actually a just looks like a big black or big solid color there. So so for example, when you look at it in the dissection microscope here, you'll see that it actually has some sediment there and some colonies growing. Now, an interesting thing with these is that when you have a TNTC, sometimes you can count it if it's too numerous for the naked eye, but if you look really closely at it in a dissection microscope, sometimes you can make out the individual colonies. Not in this one. This one's too much sediment and too many colonies that just didn't grow or grew together. Now you look at the sides, you'll notice that there's a ring around the side, and that's because of the membrane filtration, and when the vacuum pulls it through that membrane, for some reason a lot of it will be on the side as well. So anyway, I wanted to show you that with the too numerous to count. Again, this is bacteria that's grown from the Santa Monica urban runoff recycling facility, and I got this water from the influent, so the water before it hit the plant, and this was during a rain event, so there's a lot of sediment coming down in the urban runoff. So that's what I wanted to show you with this video. Another way to count these bacteria when you're counting them, there's a couple different things you can do. I'll sometimes get a little counting pen and do that, or I'll just, the counting pen will look something like this. So I'll have this plate here, and then I'll have this pen, and this pen has an on-off switch. You turn it on and then adjust it so that you can count. And I already actually counted one there. We'll press reset, and then you can go in the plate, and you can actually, each time you press one of these, it beeps. And then you actually see it, that it counted 4 right there. It's kind of hard to see. There we go, 4. So that way you can, you can count as many as you want and just beep away. And then a good thing is that it actually marks the plate when you count, so you can see that you already counted somewhere. Like I just drew that line and it marked it. So so you don't have to recount it, which is nice to keep track. It's not impossible to count it manually either. Sometimes I like to use a Sharpie and just press that when I count it. Okay, so that's the dissection microscope with the mEI and mTEC. Now let me just show you the setup really quick here. So this is a dissection microscope that I have in the lab. And another thing to do would be to use this guy here. This is a plate counter, and you can take one of these plates and put it in there and then adjust the magnifying glass by pushing it in and out. I don't know if you can see that.